Hi and welcome to our next level 2 probability video. In this video we're going to show you how to solve normal distribution problems, and this is the first video to help solve these problems. Remember, the normal distribution curve is a symmetrical bell-shaped curve and has a single peak at the exact center of the distribution. Because we take a large enough sample, the mean, median and mode are all equal. Therefore, we just use the mean, which remember is called mu, in our calculations. Remember, half the area is above the mean and the other half of the area is below the mean. Right, we also talked about the standard deviation, which has this funny little symbol called sigma. It's used in normal distribution calculations, and it's a more comprehensive way to measure the spread of the data, as opposed to the range or the interquartile range that we used previously. Remember, the standard deviation makes the data more spread out as the standard deviation gets larger. So, a smaller standard deviation, the data is all clumped together and the peak is higher. A larger standard deviation, the data is more spread out and the peak is not so tall. Right, well, let's get into some examples and show you what problems and how we can solve them using normal distribution. These problems will require a graphics calculator, and if you don't have one or can't get access one through your school or through somebody, then you will need to watch some videos later on called standard normal distribution, where you're going to have to solve things manually. Okay, example 1. The waiting time at Kiniparu Hospital on a busy day has a mean of 123 minutes and a standard deviation of 11 minutes. So here's what we're going to do. We're going to draw a picture, just a sketch. It doesn't have to be anywhere near perfect. It's a sketch. It's part of our working. So right in the middle is the 123 minutes, which is the mean. Now here's the question. Part A, find the probability, the chance a patient has to wait for more than 110 minutes. Now on our diagram, we're going to sketch roughly where 110 is, and we're going to colour in everything above 110, which is all the people waiting longer than 110 minutes. Now the area of this curve represents the probability, and we're going to use it to calculate it. So here's how we do it on a calculator. Let's go into statistics, go into distributions, which is F5, go into normal distribution, which is F1, go into normal cumulative distribution, which is F2, and here's the screen that you'll come up with. Now, let's enter in the following statistics. The lower boundary is 110 minutes, because that's the least amount of waiting time, so let's type in 110. Now, the upper boundary, there is no upper boundary. Now, I realise we're not going to be waiting forever, but what we're going to do is put in a value that's so big that we're guaranteed to cover all the greatest waiting time somebody would have to wait. So put in a very large number. It doesn't matter if you put in a larger number than what I've got, you'll still get the same value, so long as it's really large. Right, the standard deviation is 11, that's sigma, and the mean is 123. So let's put all this into our calculator and click on execute, and we will get the probability of 0.88136107, which we're going to round to 4 significant figures to 0.8814. Or if you prefer to multiply it by 100, you'll get 88.14%. All right, here's part B. Find the probability a patient has to wait for less than 2 hours. Well, here's our diagram again. 123 minutes is the mean. And here's 120, because that represents 2 hours. 60 plus 60 is 120. And everything coloured in less than that is all the people waiting less than 2 hours. Right, back to our calculator, go through the same setup and menus, go back into the screen, and now we're going to put in a lower boundary. Now put in a very small value. I know we can't get negatives, but put in a value that's less than 0 and really small. For our upper, put 120. For our standard deviation, 11. Our mean is 123. And you will get a probability of 0.39253143, which I'm going to round to 0.3925 to 4 significant figures. Thanks for watching.